Welcome back to MZ Math Online, a platform where we learn mathematics online. In today's lesson, we shall be looking at how we can multiply Surds. When multiplying Surds in a bracket, you must expand the Surds as we normally expand binomials, and then you now simplify them using the various properties of Surds we learned in our previous lessons. Now, if the Surds are not in the basic form or in the simplified form, you must first of all simplify them before you multiply them. So I think we've also learned how to simplify Surds. If you miss the lessons on properties of Surds as well as simplification of Surds, I will leave a link to those tutorials on the description. So just click on it and watch those videos so that you learn how you can simplify Surds and also how to use the various properties of Surds. You have to learn that before you now join us in this multiplication of Surds. Having said that, we are going to write some questions under simplification of Surds and see how best we can actually multiplication of Surds though, not simplification. Sorry for that. I will write some questions under multiplication of Surds so that we learn how to multiply them using the various properties and also the simplification as well. So let's have the questions written on the board and see how we can solve them as well. So these are the examples we shall be solving under this multiplication of Surds. We have to simplify the following. So we pick them one after the other and then we do justice with each one of them. The first one, we have to simplify root 7, bracket open, 3 root 7 plus 6 over root 7. So let's see how we can simplify this. So as we all know, since these two Surds are in bracket and there's no sign here, to simplify this, that means that we're going to use the root 7 to expand the bracket. In other words, to multiply by each one of the terms inside the bracket. So we multiply root 7 by 3 root 7 and also multiply root 7 by 6 over root 7. When we do that, we're going to get root 7 times root 3 root 7 will give us 3 root 7 squared. Because the root 7 are 2, so that's root 7 squared plus this multiplied by this particular root 7 will multiply by the numerator fully. Because in actual fact, if you are going to consider this as a fraction, it's over 1. So if it is over 1, this root 7 will multiply with the 6, and then the 1, that's the denominator, will also multiply root 7, and that will still give us root 7. So in doing so, we're going to get 6 root 7 over root 7. Then after this, we can now simplify this. This square will do away with the root, and then this root 7 will also do away with this root 7, leaving 3 multiplied by 7 plus 6. 3 multiplied by 7 will give us 21 plus 6. 21 plus 6 will give us 27. So 27 is the answer to the question 1. So we have been able to simplify this. We consider the second question as well. In question 2, we are going to simplify 3 root 27 minus 2 root 3, bracket open, 4 root 3 minus 5 root 12. Now to simplify this, you should bear in mind that this only these two stars are in the bracket. This and this are not in bracket. So what that means is that you're going to use the shard or the term that is closer to the bracket to expand it, and not both two terms. If the two stars here are also kept in the bracket, working it will be different from when they are not in bracket. So when we come to question number 4, for instance, we shall see the difference between that of question 4 and that of question 2. For question 2, because these two stars are not kept in the bracket, we only use the term closer to the bracket to expand the bracket and nothing more. Alright, so we can rewrite this side, which is 3 root 27. But in actual fact, root 27 is not simplified. So in the beginning of the lesson, I said that if the stars are not simplified, you can simplify it, or you have to simplify it before you can now do any multiplication of simplification. So because of that, let's, instead of writing 27, let's try and simplify that side. Now, get a perfect square that can multiply by a whole number to give us 27. I think that would be 9. Because 9 multiplied 3 will give us 27. So I just want to simplify that side. When you multiply 2 root 3 by 4 root 3, 2 will multiply 4 and root 3 will multiply root 3. So when you do that, you're going to get 8 root 3 squared. Root 3 times root 3 will give us root 3 squared. Then this negative times this negative will give us positive. Then 2 will multiply 5, giving us 10. And root 3 will multiply root 12. And root 3 times root 12 will give us root 36. Then we can further simplify this. Root 9 will give us 3, but root 3 cannot be simplified. So you multiply the result of root 9, which is 3, by this 3, and that will give us 9 root 3. We have 9 root 3 minus this square, we cancel the square root here, leaving 3. So we have multiplied 8 by 3 plus 10 multiplied by the result of root 36. And root 36 will give us 6, because 6 times 6 will give us 36. So we can further simplify by root 9 root 3. 8 multiplied by 3 will give us 24. So that's minus 24, plus 10 times 6 will give us 60. So these two numbers are like terms because they are all whole numbers, but they are unlike to this, which is a sad. So we can add those two numbers. Minus 24 plus 60. So minus 24 plus 60 will give us positive 36. So we have 9 root 3 plus positive 36. So you can also write, this is the answer to the question, even though you can also write your answer like 36 plus 9 root 3. That's how you can also write your answer. Sometimes you will be asked to leave your answer in a certain format. Let's assume that if we are asked to leave our answer in the form a plus b root 3. So if you ask to leave your answer in the form a plus b root 3, then in that case you should have left our answer in the form 36. Just leave your answer like this: 36 plus 9 root 3. So the value of a will be 36, and then b will be 9 root 3. So that is how we answer the second question as well. Now we move to the third question, where we shall be simplifying 2 root 3 bracket open 2 minus root 3 bracket close plus 2 root 2 bracket open root 2 minus 1. So let's see how we can simplify that. To simplify this, SARS, 2 root 3 will be used to expand the bracket here, whilst 2 root 2 will be used to expand the second bracket. So when we do that, we're going to get this by this will give us 4 root 3, then 2 root 3 times root 3 will give us minus 2 root 3 square plus this time this will give us 2 root 2 squared minus 2 root 2. Because any number multiplied by 1 is that number. So 2 root 2 times 1 will give us 2 root 2 again. So simplifying this, we have 4 root 3 minus 2. This root square will cancel the root, leaving 3 plus same thing will be done here. So square will cancel root, leaving 2 multiplied by 2 minus 2 root 2. So from here, we further simplify the like terms and even the unlike terms. So let's multiply first. So 4 with 3 minus 2 times 3 will give us minus 6 plus 2 by 2 is 4 minus 2 root 2. Now I want to write this expression by writing the whole numbers before the stars. So by doing so, this can also be written as minus 6 plus 4 plus 4 root 3 minus 2 root 2. So after this, we can now simplify this. Minus 6 plus 4 will give us negative 2. So negative 2 plus 4 root 3 minus 2 root 2. Now, we are leaving the answer like this because even though these two expressions, that is 4 root 3 and that of 2 root 2 are SARS. But however, we cannot simplify or subtract them simply because root 3 is not same as root 2. So they are said to be unlike SARS. And in our previous lesson, we said that unlike SARS cannot be added or subtracted. So since unlike SARS cannot be added or subtracted, we leave our answer like this. So the answer to the question will be negative 2 plus 4 root 3 minus 2 root 2. That is how we answer the example 3 as well. We move to the fourth question, where I was saying that whenever the two SARs are kept in brackets like this, minus 1 minus root 5 in bracket, 1 over 5 plus root 5 in another bracket. So how do you expand it? To expand this, we're going to use the binomial approach. The binomial, how to expand two binomials, where you pick the first term and multiply by the first and second term in the second bracket, and now pick the second term in the first bracket and multiply by both terms in the second bracket as well. So let's see how we can do that. So to expand this, we use 1 to multiply all the terms in the second bracket. You have 1 out in bracket, 1 over 5 plus root 5. Then you pick the minus 5 and do same to it. So minus root 5 out in bracket, 1 over 5 plus root 5. So after doing this, you use each of the terms outside the bracket to multiply by all the terms inside the bracket. So when you do it like this, you can now use the approach we use in example 3, where we use each of the terms outside the bracket to multiply by the terms inside the bracket to simplify this. So after this, 1 by 1 over 5 will give us 1 over 5 plus 1 by root 5 is root 5. And this by this, you have minus root 5 over 5. When you multiply root 5 by root 5, that will give us root 5 squared. Root 5 squared. So let's do the necessary simplification. We have 1 over 5 here plus root 5 minus, this one can be written as 1 over 5 root 5. That's another way of writing it. And then we have minus, square will cancel with leaving 5. So here what we'll do is that we simplify the whole number part, and then we also simplify the size part as well. So let me arrange it to make the simplification easier for us. Even though you can still simplify without making any arrangements, but since we are learning, let's arrange it and so that we'll get it easier. So we have 1 over 5, which is the whole the number part, and then minus 5, that number part 2 as well. Then we now bring the side part, which is root 5 minus 1 over 5 root 5. So as I was saying, we simplify the number part separated and also simplify the side part separated. So 1 over 5 minus 5 will give us negative 24 over 5. So we have negative 24 over 5. Then root 5 minus 1 over 5. Remember, root 5 minus 1 over 5 is like 1 root 5 minus 1 over 5 root 5. So you add or you subtract 1. You subtract 1 over 5 from the 1 here. This is actually 1 root 5. When you subtract 1 over 5 from 1, we are going to get 4 over 5. And it's positive. So plus 4 over 5 root 5. So if you are having challenge with some of these things, as I said earlier on, let's just go back and watch the properties of Surds. Some of these are actually coming from the properties of Surds. If you understand the properties of Surds very well, and also how to simplify or reduce Surds to their basic form, you need to understand that concept too before you can be conversant with what we are doing today. And I will leave a link in the description on those 2 lessons, how to reduce Surds and also the properties of Surds. Now let's consider the last example for today. Before we answer that particular question, which is example 5, please, if you have not subscribed to the channel, do so. Just subscribe and also turn on the notification bell so that you will not miss any of our future videos. And please don't also forget to like the video and also share to your colleagues, friends, so that we grow the channel together. Thank you. So let's consider the example 5. In example 5, we are asked to simplify root 5 exponent negative 2 times 75 exponent half times 12 exponent negative half. This is so sad. We're going to learn how we can simplify this as well. Before we simplify this, I want us to revise one of the properties of Surds, which is if you have a Surds like this, and they say a number like this, where A stands for any number at all, A exponent half, A a exponent half can be written as root a. So a exponent half is the same as root a. If you have a exponent 1/3 is the same as cube root of what? A. So even though our focus is on this first one, that any exponent or the exponent half of any number is the same as square root of that particular number. Example, if you have, say, 5 root half is the same thing as square root of 5, and that is exactly what we are going to apply in this particular one, and as well as this one, that particular two properties. So let's take the one. Now, coming back to the question, we have root 5 exponent -2. So another way of writing this, okay, let me just quickly add this before we answer the question. If you have, say, a exponent negative, let's say -3, the same as is the same as 1 over a exponent +3. If you have a exponent negative, let's say -4, the same as 1 over a exponent +4. So that one too, we shall be using that property here as well. So that means that root 5 exponent -2 can be written as 1 over root 5 exponent 2. That's another way we can write this. Multiplied by this, as we said earlier on, can be written as square root of 75. Multiplied by this can also be expressed as the negative will become 1 over, then the the half is the same as roots of number. So this is just a simple way of writing the question so that working it becomes very easy for us. Let's now try and simplify the surd. Let's try and simplify the surd. Now, root 5 squared is the same as root 5 times root 5. And root 5 times root 5 will give us root 25. And the result of root 25 is actually 5. So simply, we just use the square to cancel the square root. And that will give us 1 over 5 times root 75 is the same thing as 25 multiplied by 3. Well, 25 times 3 will give us 75 times 1 over root 12 is the same as root 1 plus 3. Remember, in our previous lesson, we said to simplify as you get a perfect square that will multiply by a whole number to give us the number in question. So 25 is 25 and 4 are the two perfect squares we are going to use to simplify these two surds. So after this, I'll go ahead and simplify it as root 25 times 3. The result of root 25 is 5. So multiply 5 by root 3 times the result of root 4 will give us 2. So you multiply that 2 by root 3. So you have 1 over 2 root 3. So let's continue with our simplification process. Remember, these two are fractions, but this is a whole number. So to make things simple, you can just divide this one by 1. So that this one will multiply by root 5 times this one again. So that 1 times 5 root 3 will give us 5 root 3 multiplied by 1 is 5 root 3. So we have 5 root 3 over, we now multiply the denominators. So 5 multiplied by 2 root 3 will give us 10 root 3. And then we can further simplify this. This root 3 will do away with the root 3 here. Then we divide 5 by 10. And 5 by 10 will give us half. Because 5 into itself is 1 and 5 into 10 is 2. So that answers the question 5 as well. And we have come to the end of today's lesson on core maths, where we've looked at how we can multiply surds. So until we meet again, bye for now.